Thank you.
Okay, yes, thank you, Joanne. That's correct. Dili pag-follow, wala na follow ang procedure or nagkabaliktad-baliktad, so it can also lead to errors. Okay, that's good. Who else? Do we have Nico?
For me, ma'am, one of the errors in experiment is kana wala dili mao paggamit sa mga gamit, ma'am. Kanang incorrect use of uh, experiment tools. Mga tools, ma'am.
Okay. Example. Unsa may example ano Nico? Yes, please. Nico. Example. Kaya wala paggamit sa ito to, experiment tools. Dili
So,
correct.
di ko gaon. Sorry, ma'am, kay istorya ko, di gaon akong mic. So, example, ma'am, katong magbutang kag substance, di ba? Kinahanglan kag mga container. So, kinahanglan kag maggamit og kanang sakto nga container ana nga substance, ma'am, kay og magamit kag kanang container nga dili siya kanang suitable ana nga specific substances, pwede siya mahimong error sa imuhang experiment kay na every experiment tools, ma'am, naka kuan man siya nga na ay uban nga substance nga dili siya bagay dito or di siya suitable ato nga gamit.
Yes, okay, that's correct. So, kato mga containers, you can call it glasswares. Okay, so glasswares na malipat ta when we have ano lang, we are going to measure only 10 ml, 10 ml our solute, of our solvent rather. However, ang imong gigamit is you use beaker. You use 50, you use 250 ml beaker pag yun. Alright, so it's a very big error na siya because of the calibration. So we can see na ato ang beaker, our beaker kay dagko kay calibration, dagko ihang lapak-lapak. So kibali in every line mo example that's 50, and then next line is 100, the next line 150. Okay, but you are using your 10 ml ra imong kaon, so that could lead an error. So use gamay pod na glassware. Okay. So thank you. Who else? Okay, who else can add? Okay, so those things tinig pastorya, they are systematic errors. So makontrol na sila. However, kaning mga uncontrollable. Example, temperature. Mga impurities from the atmosphere. Okay, so that could lead also to errors. And then also, sa air atmosphere nga mo surround sa atoa, and for also the speed. Okay, the speed of mixing. Okay, the type of your solutes, the type of your reactants. There are those reactants na hapit na day ma-expire. Okay, so the speed will not is not that kanang kusog compared to those new one. Okay, that could lead an error also. Okay. All right, so we have chemists usually carry three. So that's why it's important na you don't just rely on one data. You, mostly the chemists and others, they carry out 3 to 5 replicates. So when we say replicates, okay, it's the you have the same sample. We have example. I know if you have that sodium chloride, okay, say sodium chloride, and then you You dilute that one. So the replicate, when we say replicate, so we do one, two, or three or more, uh to more of to more of your to more of your experiment, and then with the same size, okay, with the same situation, or we have this one the same size, and the same procedure also at the same time and in the same way. So that's replicate. So more siyang gipadaghan nimo imuhang data, but making sure also na it's on the same time, same way, same procedure imong gina-follow, and then same size. So that's replicate. And then we also have individual results from a set of measurements are seldom the same. So a central or best value is used for the set. So after that one, if you have 3 to 5 replicates, so you're going to use statistics na dayon to determine if your analysis is true, and if it's true, how what is the significance of it, how reliable it is. Okay. So one of the statistics being used, this is very common. We have our mean. Okay, so mean is just an average of your data. Okay, if you have 5 replicates, okay, if you have 5 replicates, then you divide that one with a number, okay, number of replicates, so that will be your mean. The result of those five replicates divided by the number, so that is your mean. So gi-average ra nimo ang test tube A, that's 0.21 concentration molar. Then we have B also, that's 0.30. Then test tube C, we have 0.50. Then we have, okay, so those are your data. And then if you're going to get the mean, you just add those concentrations, and then you divide it with the with your sample list, with the number of samples. We have n. Okay, so that's it. Mean is used. However, okay, all right. So as sa to example, 0.21 molar, and then we have 0.31 molar, and then we have 0.81 molar. Okay, this is for A, and this is for B, then this is for C. Now, just looking at our data, you can say that, oh, there's something wrong with it, because they are treated in the same condition, same time, same procedure. However, there's this test tube C nga naglahi jud siya. Okay, this test tube C is what we call outlier. Kaya nahinala. So outlier, this is our outlier. And also, if we are going to use our mean to identify the average concentration of the sample, okay, of our sample, okay. So, ato ra siya i-divide, no? However, mean is, not good, not reliable always, especially if we have our outlier, if we have a data that is layo kayo, not that precise. Okay, it's not precise to the two other data. So one statistic that you are going to use with that is we will use the median, because again, the mean, if you are going to get the average of this one, the mudako ang ihang average, mudako kaayo, because it will be pulled by this outlier nga 0.81. So to avoid that one, so we are going to use our median instead. So middle value of a sample of results arranged in order of increasing or decreasing magnitude. So we will have our median, because median is you are just going to arrange and then you will get the median. So the median will not be affected with our outliers, with our values na very dako or very gamay. So median is good to use instead of mean. Okay. So we have odd number of results. Take the middle value. For even number of results, okay. So for this data class, what is the mean? Okay, for this data, what is the mean, please? We have Joanne.
Ma'am,
Okay, given these three data, what is the mean?
zero, ma'am.
Zero. Okay, we have who else? Levy.
Good afternoon, ma'am. Um,
Yes.
81, ma'am?
The
Oo ba?
mean.
Di
The
ko ma
average.
Ma'am, ako ma'am.
The average. Okay, we have John Lloyd. What is the mean using that data?
Eight, ma'am.
As, yun sa niyo po kung 8. Okay.
44, ma'am.
44, ma'am. 0.44.
Okay, so class, mean gali class, bisan asa ka mo adto, mean or average is just the sum over how many, over the numbers of data. Okay, example, so given sa many mo na pagkuhaan no Mikey. Please tell us.
Okay, ma'am. To get the mean of this 0.21, 0.31, and 0.81, you have to sum it all and then you have to divide the number of the repetition it takes. So we have 1.33, the total of 0.21, 0.31, and 0.81. And you have to divide it into 3 since it the repetition number is 3, so the answer is 0.44.
Okay, thank you. So, that's it class. Bisan asa mo mo adto. Wala siya chud. Chud na siya mausap. That's average. Mean is what we call also as average. Okay, so we have also what's the median? Okay, we have okay, no. Okay, Jerome.
0.31, ma'am.
How did you do that?
Ang middle number man ang basehan sa median, ma'am.
Just the middle number? Okay, what if unahon na kog sulat ang 0.31, 0.21, then 0.81. What's the median?
Still 0.31, ma'am.
31 sa as order man pod siguro magbase.
Okay, so yes, it still is 0.31. First, you have to arrange it from in increasing order. Okay, in increasing order. So we have 0.21, 0.31, and then 0.81. So the middle number is 0.31. That's our median. Now, class, what if we add another replicate? Okay. If we add another test tube, sige natay point, ano siya, 52 and point 49. Okay, test tube D, test tube E. So what's the, no, dapat siya 0.62. Okay, what's the Median.
0.52, ma'am.
Pila?
0.52.
How did you do that?
Arrange in ascending order, ma'am.
Okay, origin is
Then let
ascending order. Ascending. Okay, so we have unsay una?
0.21, then 0.31, followed by
One, two.
0.49, then 0.52, 0.62, and 0.81 ang last.
Okay, and then
Select
how
na
did you
dayon
get
sa
the median?
ang middle number na dayon, ma'am.
What's the middle number?
0.52. Ay, 0.49.
0.49, and then 0.49, ra? Okay, class. So if you have even numbers, okay, if we have even, I know even replicates, if just like that, example. Okay, so if we have this one, we have arranged it already. We have 0.21, 0.31, next is 0.49, and then 0.52, then 0.62, and then 0.81. Okay, if we have that one class, now we will get the two middle values. Two middle values. What are the two middle values?
0.49 and 0.52, ma'am.
I-add sila din. I-divide man
I-add
siguro.
sa 2.
I-divide din siya.
Add, ma'am, then divide.
Divide by
2, ma'am.
okay, so that's how you get our median. So our median will be
0.76, ma'am. Ay, 77 eh.
0. Okay, 77.
765.
0.77.
765, ma'am. Kung i-round off siya into two significant figures, ma'am, kay 77.
Okay, two significant figures because we have two. Okay, so that's it. That's our median. Okay, now this time calculate the mean and the median of the following data. Klaro kayo. Okay. Now, who got 19.8 as mean? Kinsay naka-check?
Ma'am, na white.
I go what? Okay. Okay, so that's it, class. Mean is just a plus. You add those data and then you divide it by the number of samples you have. Then we have okay. Question? No question with that? Question? No question?
None, ma'am.
None. Okay, so let's go. All right, so this time, okay. All right, so we have find the mean and median of each of the following sets of data. Okay, so we have we have letter D. What's the mean of letter D? We have 6 data here. 1, 2, 3, 4, 5, 6. Okay, so that's it. How are we going to solve that one? We have 4.52 times 10 to the negative 3 plus 4.63 times 10 to the negative 3 plus 4.53 times 10 to the negative 3 3. Then we also have plus 4.48 times 10 to the negative 3 all. Okay, kitsa na nakakuha. Divided by 6. Okay. So what's the mean in letter D? Okay, we have Erica. What's the mean of letter D?
Good afternoon, ma'am. Sorry for kuan ma'am inconvenience, ma'am. Bag-o po ko kasulod, ma'am. Murag naglisod kuan po naglisod pag ko adapt sa mga nanggip mga istorya, ma'am.
Okay, so we have Abines. Okay, what's the mean of letter D?
Wait sama, ma'am.
Also, what's the median, Janeline? Okay, so nakakuha na? Use your calculator, guys.
Pwede ako, ma'am.
Okay, so yes, Nico. What's the mean?
So, ako ang answer, ma'am, is 23.39 times 10 to the power of negative 3.
23. Okay, who else has the same answer to Nico?
Ma'am, ako ma'am kay 2.34 times 10 to the power of negative 3.
Okay, kinsa pa? Dahil tag-answer, guys. Okay. Who else? So, we have 4.52 again daw. Try dagbalik ninyo, class. Negative 3.
12 pa, ma'am.
Yes, how much? Sige, kinsa pa kuan 4.47 times 10 to the negative 3. Then we have 4.48 times 10. Okay. Mean.
Ma'am, pwede ako.
Yes, please.
4.54 times 10 to the power of negative 3, ma'am.
Okay, so same. All right, so that is our mean. So you just add the values, add the 6 values, and then you divide it with 6 because there are 6. Okay, so what about Okay. So what about the median? What's the median? In letter D. Okay, the median, please. No, Jerome, what's the median? Okay, so what about the median? Yes, please, Jerome. What's up? What about the median? What is the median? .53 times 10 to the negative. Okay, so the median is. Okay, I'll write it na lang.
One, ma'am.
Okay.
4.53, ma'am, times 10 to the power of negative 3.
Okay, yes, thank you. So that's it. All right. Now we have also a key. Okay, so after that, you can you can solve or you can find the mean and median of A, B, C, E, and F. So kaya nyo na yan. And then we have also the deviation from the mean R. Okay, so if we have here, ano, okay, if we are asked of the deviation from the mean, okay, deviation from the mean, it means that if this is your mean, okay, if that is your value, the deviation means pagkalayo. How much is the deviation of of each values gikan sa imuhang mean? If this is your mean, how far? How far is it deviated from the mean? From the central point, from this point, o kaninga point, if you have this value, how far is it from your mean? So how far is it? Now if you have an experiment and then you have the higher values of deviation from the mean, if dagko kayo imong deviation from the mean, then that experiment is considered to be questionable because to have for an experiment, our desired experiment is for us to give. Okay. Okay. So all right, it's okay. So we have our for an experiment, our desired data from an experiment is for it to become accurate and also precise. Now, if your deviation from the mean is very large, it's very high, it means that this value is not okay, that the values you have or the data you have are not precise. Lagyo kayo. And it's not desirable. So for us, for it to become reliable and you have good data, it should be gagmay kaayo siya og standard deviation from the mean. Okay, so later we will go on to standard deviation, which holds true to this also. Okay, so that's it. The deviation from the mean is just you have the data, you have the sample. Example, we have number one. Okay, so we have 3 replicates in number one. We have 3 samples. Okay, and then also we are asked of our deviation from the mean. So we will have 0.01 that is minus of our mean. So the mean here is this one. Okay. So our mean in letter A is 0.1063. So have you followed class?
Yes, ma'am.
Yes, ma'am.
So if you have this mean, and then also you have to calculate deviation from the mean, okay, you get the value, which is 0.01, nasya dire, and then minus your mean, okay, and then also the deviation is this one. The answer to that subtraction is your deviation from the mean. Now, if it's very dako, then that's your data is questionable. And if it's gamay, then it means that your data is precise with each others. So that is acceptable. Okay, so that's why you just cannot lie to if you are doing experiments, you cannot lie. Especially if you have kaning very master na kaayo na supervisor, then you give those data to him or her. So by just looking the data, makabalo na siya na you are doing good or you are doing not good. So that's it because the data kanang has something to say jud, makastorya jud ang imuhang data. Okay, so that's it. Now we have this one. Calculate the mean, the median for the following data. Okay, so that's it. Okay, and then we have here. Okay, so ideally, the mean and the median are identical. Frequently, they are not, particularly when the number of measurements in the set is small. So, we can use this one mean and median if it's long, small ang lang imong data. If you have, if you have 1 to 5 to 10, but if you have 100 of data, then some statistics is advice is good to use instead of the mean and the mean and median. Okay, median is used advantageously when a set of data contains an outlier. So this is one. An outlier class is a result that differs significantly from others in the test. So it is kahinahinala, it is the one na matingala ta. Katingalahan ka if you have the data 0.21, 0.31, and then you have the data of 1.11. So this data is what we call our outlier. Now, if there are tests we are going to use if we are going to accept or reject this data. Okay, so there are tests we are going to use on that later. Now, if you have this one class, if you have an outlier, if you have a very small and very big number in the set, then it's good to use our median because median will not be affected by this one, by your outlier. Only your mean can be affected because the mean class is ba siya, average. Now, if we have this one, we add this one, we add, and then we add. So this one participates in your data, in your solution if we have our mean. But if you have median, then this one cannot participate and this one cannot participate, only this one. So median is used advantageously when we have an outlier. Okay, an outlier can be very big or can be very small. Something that differs significantly from the others. Okay, we have here. He says that madunggan na ko class, dili ko putol-putol or putol-putol.
Madunggan ra,
Dili
ma'am.
ka.
Okay, so naka-follow ra mo class.
Yes, ma'am.
Isa ra pod ang naka-follow.
Excuse me, ma'am. Kusog kayo ulan diri sa amo, ma'am. Nang putol-putol medyo gamay gyud.
Kinsa man ni si Erica?
Islet, ma'am. Pero okay naman, ma'am. Kanang may sit is ma-islit-islit tayo mong tingog dito sa'yo, mapupot pud lagi. Ulan kay diri sa mga ma'am, oy, balo ka sa uban.
I see, I see.
Ulan po.
Sige.
Ulan
Ulan po
kay
din.
Dari wala noon gaulan, gaulan pud ganina mo. Ulan na pud ni ron, ulan wala mong good. Ulan ulan din init na pud gamay. Okay, so let's move on lang gihapon. So we have the mode. Okay, so we have tananano, we have three. We have sa mean, median, and the mode. Okay, the mode. Okay, so the value that occurs mostly frequently in a set of determinations. Okay, values that occurs frequently in a set. Okay, example of that. Okay, if we have 0.21, 0.31, no. 0.31, then also we have 0.41, then 0.11, then 0.31, 0.51. Okay, what's the mode?
0.31, ma'am.
0.31, ma'am.
Right.
0.31.
Okay, so it is the value that occurs most frequently in a set. So that is your mode. Okay, so if you have that data also, then some, that they use this mode na lang kung sa to nag-repeat, especially if there's no outlier, then it has this one, 0.31, dugol kaayo, then they will use the mode in identifying their data. So we have also here, we have precision and we have also accuracy. When we say that our data is precise, what does it mean? We have Swan, Francis Grace.
It tells how close the results are, which provided that they are obtained in exactly the same way, ma'am.
Okay, it tells how close to each other, no? How close to each others. That's precision. What about accuracy? We have Jomar. Okay, Jomar, what's accuracy? Okay. All right.
Ma'am, try. Let ma'am.
Okay, Erica.
For me, ma'am, accuracy refers to how close measurement is to the true or accepted value. Thank you,
Okay,
ma'am.
yes, accurate. Now, if you have, na dili man na accurate imong timbangan. Okay, imong timbang, di ko ano imong bugas kay di accurate. Dili siya. Layo kay siya timbang sa pikas timbangan. So, you have example if you have 10 kilos and then imuhang imuhang timbang na palit nga bugas is na only 9.2 kilograms. So, mo na kadili siya accurate. Di siya pariha kayo sa ato ang true value. So, it means that our accuracy indicates the closeness of our measurement to our true value. So, the precision is how close to each others. How close sa imuhang mga samples. Okay, precision. All right, now we have, let's go. Okay, three terms it deals with repeatedly. Okay, three terms are widely used to describe the precision of a set of replicate data. So we have standard deviation, variance, and then we have coefficient of variation. So we will encounter these formulas: standard deviation, variance, and coefficient of variation. Okay, so we have accuracy. Okay, so we have that accuracy. It is the closeness of the measurement to its true value. Okay, and also there are also in an accuracy class there it is expressed in terms of absolute error, and we also have relative error. Okay, so absolute error, it is ano, it is your this one. Wait. Okay. Class tagag mo ra lagi kita mag ano no, magklase. Inani pud mo sa uban.
Ulan man gud ma'am basin wala sila
Ning
kasulod
brown
nila
out
wala
pod og kalit
kasulod
ma'am dayon sa uban pod nga kuan ma'am nawalang signal kahing bagyo.
Lagi po. Kanina bitaw ga klase po ko sa akong in org. Ano, 1 hour me kay na lobat na akong laptop na nag brown out po diri noon. Okay. All right. So we have absolute error. Okay, absolute error is just ano, you have your value and then you minus that one with our true value. So it's absolute when we say it's absolute siya na siya. Okay, so x. All right, so that is your absolute error. Now we have here our relative error. Relative error is in terms of our, in terms of percentage and in terms of our PPT if it's very small. Parts per thousand. So we have this one, we have this formula. We have, it's only, relative error is just an absolute error over the true value times 100% or 1000 PPT. Okay. So it is the ratio of the absolute uncertainty in a measurement to the value of the uncertainty. Okay. So we have that one. If okay, now let's go to, all right, this one. We have, okay, we have this sample. Okay, a method of analysis yields masses of gold that are low by 0.4 milligrams. Calculate, okay, it's already low of 0.4 milligrams. Calculate the percentage or the percent relative error caused by this result if the mass of gold in the sample is, if we have this one, and if we have this one, and this one. How would you do that? We are asked of our relative error. Relative error is this one class, no? By presentment daw, we have this formula. Okay. We have this formula. Okay. So let's write that one. Okay, so relative error. Okay, we have ER, error relative. ER is equal to xi minus xt over xt times 100. Okay, percent. All right, so letter A, if we have 500 milligrams, so what is the error? What is the relative error? So we have this one class. In the problem, it is already stated that the mass of gold that are low. Okay, so it has, ano na, it is low of 0.4 milligrams. So this is the discrepancy, no? So that one, so we will just copy 0.4 divided by the true value. The true value is this one, 500 milligrams, then times 1,000, 100%. So our the mass of gold has decreased 0.08%. Okay, 0.08%. Now, letter K. What about letter D? Okay, we have Mig. Can you calculate letter D? If you have 70 milligrams, it has load 70 milligrams. So it means that the initial mass of our gold is 570. Okay, so we have letter D. Mig. Okay, Nico.
0.57, ma'am.
How did you do that?
By following the formula, ma'am, ang initial, so siya kanang x sub I kay
Yes.
0.4 divide by
Letter D
x sub
kanto.
t, which is 70 milligram times 100%, ma'am.
Okay, so follower siya kay ano naman na siya dire. Okay, so that is 0.57. Okay. Did you try that with your calculator?
Excuse me, ma'am.
Yes, ma'am. 0.57 ang kuha, ma'am.
Okay. All right, so that's it. Okay, so you do na lang to the other letters. Okay. Activity na lang ko, no? Okay. And I'm answer. Okay, so over the trash line. All right. So same thing. So okay, so makasolver mo sa 5.10 and 5.11. Kaya 5.10. And then we are asked of 5.11. So class, you just practice the problems. Okay. Mostly they have the same same treatment to what we've done. And then the others will follow our gihapon. Okay, so that's it. It's still japon. We have the relative error. So you just do you follow the formula of relative error. Then we have our illustration here. So what about letter A? Okay, what about this letter A? Okay, so what do you think of this diagram here? Of this illustration in A? Picture A. Does it has low accuracy, high accuracy, or high precision? Now here, X here, kusog kang hangin. X here is your, okay, X here is your true value. So it's your true value. Now, what will happen? Then the dots here are the replicates. So your sample data. Data.
Low accuracy, ma'am.
How is the accuracy?
Low, ma'am, for me. Kay, do layo ra siya sa true value, ma'am. Kanang sa X.
Yes. Who was it? Erica. Okay, very good. You are correct. Then we have, what about the precision? Is it precise?
Low sad, ma'am.
Okay, low accuracy. Then we also have low
Low precision.
accuracy. Then we low precision. What
Precision.
about let illustration B? Illustration B. How is
Low,
it?
low sad, ma'am.
Say low niya.
Same with
Low
letter
Low,
A,
accuracy,
ma'am.
ma'am.
low
Ha?
accuracy and low accuracy and low precision also, ma'am. Kay layo ra gyapon siya sa X, which is the true value sa paan
Okay. Oh, you
illustration.
misinterpret. Okay, thank you. So we have when we say accuracy, when you say accuracy, you look at the I know the true value. How are the replicates close to the true value? But if when you say precision, how are the replicates close to each others? Close to each others. Now,
Ah,
letter B.
High precision, ma'am.
Okay, high precision. Now, letter C. Letter C.
High accuracy, ma'am.
High accuracy. Then,
high precision,
High
ma'am.
High
precision.
precision, ma'am.
No
okay,
Ay,
what
precision.
about
low.
letter
Low
D?
precision, ma'am.
Low precision. Okay, yes.
Ay, kinahanglan gyud ay sa dikit, ma'am.
Yes, can duol jud kay para makaingon jud ta that your data is reliable. Low precision. What about letter D?
Eh,
High
tanan, ma'am.
High
accuracy.
High accuracy.
High
accuracy and high
accuracy
precision.
and
Okay,
high
so if you
precision,
are
ma'am.
the if you are the chemist, which would you choose? Letter A, B, C, or D?
Illustration D, ma'am.
Letter D. Letter D, ma'am.
Yes, letter D because D has high accuracy and high precision. That is our desirable data. Okay, so we have that one. Now this one, determine the absolute error and relative error in present and PPT, and for the mean in example 1 above given that the true value is 20.0. Where is above? Okay, I see this one. Okay, so if we have that one, okay. Calculate the mean and the median for the following. Okay, so I will assign ha. We have Jomar calculate the mean. We have Joanne calculate the median. Then letter B we have edges. Okay. Okay, so in present imo edgy and then we have bujungan for PPT. Madunggan pa. Okay. Okay, are we good?
Yes, ma'am.
Okay.
Ma'am, gusto kayong ulan, ma'am.
Like, you know. So what's the plan? Plan B. Okay. All right, so let's move on na lang ana. Okay, so I will give na lang more problem solving for you to solve, which will be your quiz, and then let's have let's have our exam. Okay, so let's go to the types of errors. We have random error, okay, or what we call the indeterminate. So this error is mostly they are can it be controlled? They are uncontrollable. So example of this one uncontrollable na di should ni is we have we have the temperature. If the temperature fluctuates, so that's unavoidable, that's uncontrollable. Okay, we cannot we cannot handle that one. Okay, but still naapamanjapon na siya but that temperature fluctuation is considered to be in random error. We also have the pressure, if there's an increase or fluctuation of pressure, that's random error. Okay, then we also have systematic determinate error. Okay, systematic causes the mean of a set of data to differ from the accepted value. So it causes the results in a series of replicate measurement to be all high or to be low. So the errors class, this one, the measure it the things that can cause high or low of our measures, it does not only apply to systematic error, but it can also do the same with our random error. Our systematic error, example of systematic error is we have flaws in our equipment or experimental design. So as you have told earlier, na kung wala nag-follow sa procedure, so that is systematic error. That is certainly avoidable. That's controllable. And then we have also the equipment. Okay, if you use other equipment instead of this one, so that belongs to our systematic error. Then also we have our gross error. Gross error occur only occasionally. Occasionally, so this one is more on clumsiness. So if you are in a laboratory and you are out of focus, so mao na siya. Example of the error example is we have spilling. If you have spilled, nakaidayabunin mo ang solution, or if you have splashing, okay, splashing, wa ka kabantay, nag-splashing na imuhang giboil. And then also we have overboiling. Overboiling. So that's it. Or we have nasayop ka og butang sa imuhang sulyot. You have put a different solute to your test.
Nawala si ma'am.
Oh, nawala siya.
Mag-out na ta.
Tala na.
Okay, class, let's continue.
Oh, nagtabi ko, nawala. Hindi ko. Alright. Okay, so dili na putol-putol ako tingog.
Dili ra, ma'am.
Kanan ma'am.
Okay, let's go back. Okay, nag-data ra ko. Okay, so again, so repeat the systematic error.
Sa gross ma'am.
Sa
Sa gross na ka, ma'am.
gross
Yes ma'am,
error.
sa gross na to, ma'am.
Sa gross error naman.
Okay, so the gross error is more on. Okay, so it's more on it's more on kining being out of focus in the laboratory. So you have spilled. So occasionally, occasionally spill. That's the case. So that can lead to errors. Then that belongs to our gross errors. So okay. Then we have also. Okay, so that's it. We have random error caused by condition. Then we have also our systematic, which is our systematic error is we have ito yung mga samples ganina, so they belong to systematic error. And then we have also the types of sources of system. So instrumental error. So maybe on the glasswares used at temperatures that differ from their calibration. So there are those na nag-differ of calibrations. Then we have our containers na doubt na we have distortion of our glasswares. So also caused by imperfection of measuring devices and stabilities of the power supplies. Okay, instrumental error. So if you are doing, if you're doing spectroscopy, so I know you are using power on that, and then there's a power interruption, then that could lead to systematic error. Okay, just like what we are doing here, if you are, if you are analyzing your data, then if there's an error, if there's a power interruption, then that could lead an error too. If you are, it will be affected by power interruption. So that could cause two errors. So because there are those there are those reactions that needs to be analyzed immediately and na dili na siya pwede paugma-ugmaan. So, you if masunod pa na maugmaan pa, then that could lead to errors na siya error. Then we also have the errors in original calibration. Kind of class, example class, there are different calibrations na jud. So we have, if we have our timbangan gali, ang isa kay wala na calibrate og ayo, ang isa pod lahi pod yung calibration. Gi padako iyang gipaubos og ayo para inigkuan timbang pod niya, daghan kay siya masulod. More ka na ragong mamaligya sa merkado, then they change the calibration, i-change nila calibration for them so that it will serve them very well. So that's an error also. The same thing also in our gaswares, there are errors in calibrations there. Then we also have contaminants on the inner surface of the containers. Okay, class, if before you use your containers, before you use your glassware, rinse it with distilled water. So last time we have used our filter funnel. Even class, if nahugasan na siya gikan, before you use that one, you will wash it with that will be magawas. Okay, so that's the instrumental error. It's more about the equipment. And then we have methodic. So the methodic, this is more about what? Okay, may I know from Asoy, what do you think is methodic error?
Excuse me, ma'am. Wala may makita sa screen, ma'am.
Ganina ra? Okay. Okay, so what do you think is methodic error?
Ma'am. Hello, hello, ma'am.
Yes.
For me, ma'am, is kanang wala bitaw mi kuan ma'am mi sunod sa kanang method ma'am sa experiment. That's why tawag siya methodic error.
Okay, so who else?
Try, ma'am.
Okay, Janine.
Kuan, ma'am, kanang methodic error are caused by adopting defective kanang experimental methods, ma'am. Kanang for example, kanang in volumetric analysis, ma'am, the use of an improper indicator, ma'am, leading to wrong results. That's all.
Is that methodic? Okay, who else? Ano? Yes, please. Okay, Jomar.
Methodic error, ma'am, from the word methods, that sa ato ang experiment natay mga methods nga ginasunod. Then for example, ma'am, sa ato ang sa about sa reaction about this kaning elements, then sometimes kung ma-incomplete yung reaction or naay something nga kanang nasayop bitaw siya or kanang slow ba yung pag-react mo na usa sa example nga makaingon taog na ay methodic error nga nahitabo sa imong experiment, ma'am.
Ako, ma'am, try.
Okay, yes, please.
Naay kuan, ma'am, naa siya methodic error kung ang value nga na-obtain is different from the process of measurement or sa real value sa experiment, ma'am, or sa experiment.
Methodic. Okay, thank you. We have, all right, so Francis. Okay, so when we say methodic class, it arises from our non-ideal chemical or physical behavior of our system. Okay, so in a system, example, if it's a closed system or an open system, and then once there are reactants that that are very slow, and there are those that are fast. So instability of those things will lead to methodic error. Okay, so this can be minimized by proper attention to our chemicals. Okay, so we must make sure about its expiration, its newness, because some of chemicals may not, may not react the same to the one that is very new. So there's an instability of our reactants. And also non-specificity of our reagents. So if we have that one, okay, so there will be an error to that. So this is more on our system. It's more on our system, not more on us. It's not more on us, but it's more on the system. Some reactants will proceeds very slow, some proceeds very fast, and some proceeds completely because it's very fast, and some proceeds incompletely because it's very slow. So that is in methodic error. So it's not ideal. So you are expecting something and then you are given with that one. So it's non-ideal chemical or physical behavior of our system, of our analytical system. That's methodic error. Now we also have another personal error. Personal error, this is more to us. Okay. More to us. So we have this one. Okay, we have carelessness. Attention, when you look at your kaning katong graduated cylinder, diba? Graduated cylinder, it must viscous. Class, when you have a graduated cylinder, diba na siya? Cylinder. Okay. And then when we say lower meniscus, it down the curve. Mao niya to lower meniscus. Then for our upper meniscus, this one. Cause if it is especially not colored, so yung eyes okay, so that one, if ma-change niyo na, that is in personal error. Experimenting the level of the liquid between two scales as two-scale division. So there is a discrepancy on that. That belongs to personal error. Okay. Now, if also we are going to titrate, later on we are going to titrate. It is a process of adding reagents for us to achieve another reagent. So it's more on color. Now, if you are color blind, so that would be a personal error. So that's it, personal error. Okay. Okay, so we have classifications of systematic errors. We have our constant error. Then when it's constant error, it is independent of the magnitude of our measured quantity. Okay, constant error. It's the same. Okay, the same error. All right, we have independent. This is independent of our magnitude, the amount of our quantity. So the magnitude stays essentially the same as the sizes of the quantity measures is varied. So this error, it becomes less significant. Okay, so the constant error is less significant because constant error does not vary. It does not vary. It's independent. So if you are going to increase your concentration or if you are going to increase your volume, so if the error does not depend on that, di po siya mo taas, depending on your volume, so that is constant error and sometimes it is less significant. Okay. It becomes less significant. So constant error. Sometimes it's manageable. Less significant. Now, if we have proportional error, this proportional error should be avoided because when you increase, okay, if you have replicates, replicate A, replicate B, and replicate C. Now, if you are going to increase the volume of your replicate or your sample A, then the volume of B also you increase, then the volume of your C also you increase. Now, if there's a proportional error that is present, that it means your analysis or your data is very erroneous because the error there is increases also depending on the concentration of your test tube A, test tube B, and test tube C. So kung padakoni mo yung volume, mudako siya. And then if padakoni mo yung concentration, mudako po di mo hang error. So this one should be avoided. From the very start, you should avoid this proportional error. Kay dili siya pwede mahimong less significant. It's very significant. Your data, your analysis will be much erroneous when you have this proportional error. Now, example of this is when you have interfering contaminants, especially the contaminants there are very reactive too, then that will follow to your reaction. And example, determination of copper based upon the reaction of copper 2 ion with the potassium iodide to give iodine. Copper 2 plus with Ki, then you will lead with I. First, the quantity of iodine is measured and is proportional to the amount of copper 2 in the sample. Okay, so if iron 3 plus is present, it will also liberate iodine from potassium iodide. So this one, okay, the presence of iron 3 plus, that is proportional error, because this iron 3 plus, this will also yield to iodine when reacted to our potassium iodide. So this pamati nato nga sakto atong gikuha because we are calculating the iodine concentration, but then you have sayop kaayo ka because instead of using your copper 2 plus, you have used your iron 3 plus. Iron 3 plus and copper 2 plus has the same yield. So pamati nato check. But no, but you have an error because instead of using copper, you have used your iron 3 plus. So this one is proportional error. Okay. So okay para class, happy na mo lang nako. Okay, ulan pa diri.
Sige, ma'am.
Madunggan pa ko.
Yes, ma'am. Madunggan pa.
Madungog pa, ma'am.
Putol-putol lang, ma'am, pero makahira.
Wala rin matingog, ma'am.
Dealing more on the systematic error rather than on our random error. Because again, why man nga nag-deal tagay sa systematic error? Because Jerome,
ay kuan man ma'am kaning sa mas daghan man ang error kaysa sa systematic, daghan ang error sa systematic kaysa sa random, kay usually kuan man gud ni murag sa nagdepende gyud sa kaning sa ato abang kita mo kuan sa experiment.
okay, thank you. You have a point. Now, who else? Okay, we have Joanne.
Excuse me, ma'am. Pwede balik ko ng question, ma'am?
Why are we most dealing to systematic errors rather than the two? Rather than we also have the gross error. Ngayong systematic error man ta naga-focus or mag ato siyang gitagan og more attention.
Okay. Kuan, ma'am, kay nganong naga-focus ta sa systematic error because ang systematic error man god kay ma-minimize siya og kanang kailangan siyang tagaan og kanang more attention gyud kay kanang self-discipline man gud ang need sa kuan systematic error. Like for example ato sa kuan sa pag-follow sa procedure. So naaman na sa atong self jud kung i-follow nato ang katong sakto nga procedure para kanang unsa kay na maiwasan ang kuan kanang mga error, ma'am. Tumato siya, ma'am.
Okay, thank you. Thank you, Joanne. So here we are dealing more on the systematic error because systematic error are controllable. Makontrol na siya. Whereas our random error, they are sometimes uncontrollable. However, napadyo point na makontrol gyapon siya. Pero less kay because it's more on the condition, more on the example, temperature fluctuation, pressure fluctuation, whereas this systematic error is more about us. So more on the process. Okay, more on the tools. Okay, so we have systematic instrument error. Okay, so we can detect systematic error and we can avoid that one if we use correct calibration. Correct calibration of our equipment. Then periodic calibration of the equipment is also desirable because the response of most instruments changes with time as a result of wear, corrosion, and mistreatment. So, like our balance, we have to calibrate that periodically. So, mga kay matindahan, na adjust ka na periodic calibration, ay mo na adjust sa mga tindahan sa merkado nga, kuan, mga taga-munisipyo or taga-asa nga ipang-calibrate sila mga timbangan kay as time goes on, there will be ma-change ihang calibration because of corrosion and then mistreatment. Then we also have systematic personal error. If it's personal error, self-discipline should be okay. So we have to have self-discipline. A good habit is to check the instrument readings, notebook entries, and calculations systematically. So the proper also nakabalot mo calculate and then we enter the data. Okay, mostly in laboratory or in an Quanport laboratory, we will enter data in an Excel also. But since di man nato pwede, so we are in our virtual laboratory. So we will be also using Excel. How to use Excel as our notebook where we put entries of our data. Then we have our systematic methodic error. Okay, so analytical method has its biases and difficult to detect because the methodic error, it is more on the system. So, it's difficult to detect, but however, it can be minimized gyapon with proper attention to our chemicals. Okay, so we have also the detection of systematic error. One of more the following steps to recognize and adjust the systematic error in analytical method. We have also analysis of standard samples. Okay, class, aside from our using our central tendency, our mean, median, mode, aside from that one, we use standard samples, standard reference materials. So, if we are going to have test tube A, if we are going to test tube A, then we will compare that one to our SRM. We have standard reference material. Okay, so that one also can be used. So instead of ato ni siyang i-treat with other nga katong replicates, so we will compare this one to our standard reference materials. So in that case, because there's a standard na siya, systematic error will be detected na po siya. So analysis of standard samples. Standard material can be purchased or sometimes prepared by synthesis. Okay. So that's it. We have standard reference material. Okay, we have SRM can be purchased from number of governmental and industrial sources. So we can buy that one, the standard reference materials. Okay, then we also have independent analysis. Independent analysis, a second independent and reliable analytical method to be used in parallel with the method being evaluated. Okay, should differ as much as possible from the method. This minimizes the possibility that some common factor in the sample has the same effect on both methods. Okay, so we have 3 replicates already. If we have test tube A, B, and C, now Also, di ba, when we say replicate, it is, it has undergone the same condition, the same size, same treatment. Now, if we have independent analysis, we will also use independent analysis for us to be really sure na ang kani di ay, there are those data na maparehas na to na they are the same or precise kayo siya. Precise because one way of that also na basin na balik-balik na imuha wrong na method, so makayon ta precise. But to make sure that we will also use our independent analysis. When we say an independent analysis, there is something that has changed. Now, you compare this one if this is really true. Okay, so we use an independent analysis. Then we have a blank determination. Okay, blank determination is just like it can also be used as something marag or standard material. So just that blank determination is you are the one who prepared this one. The SMR, we purchased that one, but this blank determination, marag imuhang kumera the class use and decide this one, that one. Okay, also variation in the sample size because we can also detect constant errors from this one. Constant errors. Kay, di ba, ito, there are those nga mag-vary po siya, mag-depend siya sa concentration, depend sample size. Okay, so we have that one. So that is variation in the sample sizes. So we can detect that one. Systematic error can be detected from variation in sample sizes. Okay, then we also have blank determination. Blank determination. So in blank determination, you contains all agents in the analysis other than your sample. So dili na to siya tangan ng sample for us to have a blank. Okay, blank means no sample. So blank. Then we have SRM. Okay, SRM, standard reference material. You purchase this one. No, sorry. Okay. So that's it. Okay, so that's all for today's class. I hope you will read. Money. I will give. And then after that one, we will check and then we'll have our exam next week. Okay, so I will give the ano ha. Okay. Ano, sa money. Question class. Hello.
Hello, ma'am.
Ay, about sa video,
Wala,
ma'am.
ma'am. Nan, ma'am.
About sa ani nga video, ma'am, ba kanang i-upload ra nimo sa YouTube, ma'am? Kay wala man gud ko kasunod.
Sa Google Classroom na lang, ma'am, i-upload, ma'am, o pwede.
nagtabi-tabi ko, wala na dungog. Ay, kinaka. Okay. So again, I will teach pod saon to have your calculator so that you will not write anymore finding the mean or unsa the standard deviation. So very easy, all in the calculator. So sayo na atong exam class. Kaya ninyo ni. Then also, I will give you problem sets. So inana. So probably the exam will be on Thursday. Hope we can finish. And then basin. Okay. So then what about your laboratory?
Ma'am, dili to
Finish?
ma-extend.
Ma'am, pwede mo hangyo mi ato, ma'am.
Pwede mi
Galisod
mo
man.
hangyo, ma'am.
Lisod
Ay.
kayo, ma'am.
Na extension na
Anong
Wala
galisod
pa
na
mi nang
to, ma'am.
Abi na mo solve lang ma'am ba para tayo mong gisyo naman dai siya process. Ako nauman na sa solving paglantaw oy naman dai ni procedure.
Oh, the procedure. O, di ba? Di ba ato maputong gidubuhat? The procedure is first, we calculate the amount. And then, we kuanda yon, we pour. So the verbs use the verbs pour, add. Okay, inana. Diyon, transfer. Okay, also take note of the glasswares you are going to use. Inana, the procedure. Kay later, abot ninyo sa high school, you will do that one man. You will make your own jud nga laboratory. You will make your own procedure. So it's important. Aside that, you know how to prepare solution, and then at the same time you can share your knowledge by writing it in a procedure, by writing the procedure. Inana. So, that's nato. Gamay naman to procedure class. Mga 1 to 5 or 6, 7. If number 1 should is to calculate. Okay.
Murag
What
7,
else pa should?
murag madala tog 7 guro ma'am.
Oh, 7. Oh, that's it. Maura. What else pa should?
Indot jud untag na atoy
Nangutana sila ma'am, extend pa daw to ma'am.
Pwede unsa man, pero you can pass.
Wala man gud to na record. Mao mo tayo na record.
But you can
Indot
pass the
untag na
activity
i-record mo.
1.
Kay
Yes
Activity
ma'am.
1 ang
Ang amo
manamo
ang
sa
kuan ma'am
inra.
katubang record natong na record nimo ma'am.
katong wala na record, ma'am.
Murag
Lisod mi ato.
atong
sa
na record lang
eksperimento,
ma'am ba? Pwede mga yung video ato ma'am.
Asa ato ka to? Activity 1, activity 2.
Murag na record man ata to nimong activity
Sa
2
1,
ma'am.
ma'am, katong wala na
Activity two.
record.
Activity 2?
No, ma'am, sa activity 1, ma'am, kay wala bitaw na record, ma'am. Di mi ka review ba? Muhang ta mi, ma'am, kung pwede ra ba tong sa activity 2 na lang ang himuan, ma'am, kung okay ra nimo.
Activity 1. Activity 1. Naka-record ko half. Naka-record ko dito half class. Okay, I'll send. I-try na ko half kung nag-send tong kuan Google. I-upload na lang na ako. Okay, so, alright, so extension. Okay, pwede pa Friday. Since wala pa labo Friday. So, the next laboratory is sa sunod. Determination of potassium permanganate. So, that's it. So, that will be on Friday. It's by Tuesday, no? Then Friday. So that's it. Question.
Excuse me, ma'am.
Yes.
Kanang by pair to siya, ma'am, pero individual mag-pass ato, ma'am, sa Google Classroom.
Oh. Oh, yes. Individual. So you can ask from your pair. Okay, from your pairs, ay mapapass. And then individual lang po ang pag-pass. In the G class. So, the record ko ato, I'll send ha. I-check sa anak ko. Okay. So, ang activity 1 day ang lisod. Okay. So, that ends our lesson today. Hopefully, we can meet on Wednesday to finish. And hopefully, okay na po ang panahon. So that we will, exam na din ta. So, okay ra class.
Ma'am, ang
Hello,
exam, ma'am.
Larry
Thursday
Maniho.
next week, ma'am.
Week.
Okay, ma'am. Thank you.
Ah. Sa inyong statistics, because this is more on statistics. It's more on the treatment of data, treating your data. Okay. So thank you so much. That's all for today. Have a great day. Bye-bye. Thank you for coming and thank you for attending our lesson.
Bye, ma'am.
Bye, ma'am.
Thank you,
Bye,
ma'am.
ma'am. Thank you.
Yes, goodbye.
Goodbye, ma'am. Goodbye, everyone.
Meg! La. Ay, wala.